Hello everyone, welcome back to Piezo Physics. In this particular video, we are going to see one different kind of projectile motion. It will not be on leveled ground, but it will be on a inclined plane. Okay, so consider one inclined plane here, which has angle of alpha. The angle of inclination is here alpha, right? Now, what we are going to do is we are going to throw an object from the bottom of the inclination with the angle of projection of theta. Now, this object is going to be projected along this trajectory, and suppose this object is being landed over here, right? Now, what we are going to do is this bottom point, we will consider it as a origin, and our coordinate system is also going to be in this particular direction. This is y-axis, this is x-axis, and this is also angle of inclination alpha, okay, with the horizontal direction, right? Now here we have to find two parameters. One is time of flight, second is range. Okay, now here consider one thing, that we are going to find two ranges. One range along the inclination, and second range along the horizontal. Okay, so here also we have to assign two kind of accelerations in the x direction and the y direction. Consider object is suppose here, so gravitational acceleration is going to be in this particular direction, right? And it has cosine component in this particular direction, which will be g cos alpha, because this is alpha, and this is g sine alpha, right? So if object is being projected with the initial velocity u, so the initial velocity's x component will be u cos theta. So ux is going to be u cos theta, ui is going to be u sin theta, ax is going to be minus g sin alpha, ay is going to be minus g cos alpha, right? Now here we are here we are having two kind of ranges. It's like this. This is alpha, this is ri, this is rh. Okay, so here I can write cos alpha, basically range along the horizontal divided by the hypotenuse, which is ri. So these are few parameters which we are going to use in our calculation, right? So our first parameter of the this particular theory is time of flight, right? So we are going to have two coordinates. One coordinate is x, which is uxt plus half axt square. Y coordinate is uit plus half ayt square, right? Now here you can see that when object is going to be landed in this particular direction, its y coordinate is going to be 0, and x coordinate is going to be range along the inclination, right? So here, what is y? Y is 0, ui is u sin theta t plus half this minus g cos alpha into t square, right? So this is going to be u sin theta into t. This is half g cos alpha t square. So time is going to be 2u sin theta divided by g cos alpha, right? So this is our time of flight in case of inclined plane, where alpha is your angle of inclination and theta is your angle of projection. Okay, so this is our first formula. So the object will take time t equals to 2u sin theta divided by g cos alpha to be landed over here. Okay, Now we have to find range. So here we will find range h, horizontal range, using the formula ux into t, because you can see that ux is the ux is its because in the horizontal direction, if you can remember in because in the horizontal direction, if you remember in our theory, there was no acceleration along the x direction. That's why it is uxt is the, that's why using this formula you can easily calculate horizontal range. Okay, now what will be horizontal range? RH is going to be ux into t. What is ux? Ux is basically, now here it will be u cos theta plus alpha, because the total angle from the with respect to horizontal is theta plus alpha, and time of flight is 2u sin theta divided by g cos alpha. Okay, so our range along the horizontal will be 2u square sin theta cos theta plus alpha divided by g cos alpha. And similarly, I can find range along the inclination equals to range along the horizontal divided by cos alpha. So it will be 2u square sin theta cos theta plus alpha divided by g cos square alpha. Okay, so we are going to have two kind of ranges. One is range along the horizontal, and second one is range along the inclination. Typically, this kind of problem, which includes projectile motion for the inclined plane, it is rarely being asked in the exams, and but you have to remember these particular formulas to find any kind of parameter if it is being asked. Okay, that's all for this particular video. Thank you so much. Stay connected to the channel.